Hello and welcome to another section of further maths. Today we'll be looking at the topic product rule in differentiation. But before we continue, I would like us to review our previous lesson. Okay, welcome back. When we started differentiation, we stated something about these various rules. I stated something like the quotient rule. We stated the quotient rule. We stated product rule. We stated multiplication, rule of multiplication. We stated rule of division. That is, this is multiplication. This has to do with quotient. We stated addition, and so on when we started. Now we've done in our previous lesson, we did something about multiplication of this, division, addition. Today I would like us to go straight into dealing with the product rule. Now when we started, I stated clearly that product rule is given as if y is equals uv, then dy dx is equals u dv dx plus v du dx. This rule is called the product rule. This is the product rule. If y is equals uv, then dy dx is equals u dv dx plus v du dx. For example, if you have let me say example 1. If you have, if y is equals let's just say x cos 2x, find dy dx. You know, this is a product rule because we have a separate function and this is also a separate function. So in dealing with this, let's start applying this. Let's call this Ru and call this Rv. So we apply the same rule here. So dy dx will be equals, now the first thing is write down u, then look for dv dx. That is to say, you're differentiating dv dx. If v is equal to cos 2x, now dv dx, that's differentiation of a sine cos. If you differentiate cos x, you know you have sine x. So dv dx will now be sine x. But why differentiate? You now be, we have minus sine x, so you now have minus 2 sine 2x. So if you differentiate cos x, you have minus sine x. So if you differentiate cos 2x, you have minus 2 sine 2x. So this becomes x multiplied by minus 2 sine 2x. Then we have the plus sign, close your bracket, plus our v value is what? Cos, because this is the formula we're using, v, these are v, cos 2x, then du dx. This is u. Remember, our u value is equal to x. So if you do du dx, remember the rule, x means s raised to power 1. So let's apply the rule here. You bring down 1 back, 1 x raised to power 1 minus 1. So which is 1 raised to power 1 minus 1 is 0. So x raised to power 0 is 1. So this is 1 times 1, which is 1. So differentiation of x gives us 1. So times 1. So from this, dy dx is now equals, let's go ahead with our multiplication. We now have x times 2 x times this gives us minus 2x sine 2x plus cos 2x. So write it down properly. You now have cos 2x. I just brought this one back. Cos 2x minus 2x sine 2x. So this is our value for dy dx. So if you have a question y equals to x cos 2x, to find the dy dx, your answer will be cos 2x minus 2x sine 2x. Now I would like us to solve question number 2 to enable us become more acquainted with the product rule. Now let's solve this other question. If you have y to be equals x cubed sine 5x, now I want you to find dy dx. Remember the rule. This is a product rule. This is u and this is v, and if y is equals uv, according to product rule, dy dx is equal to u. Our product rule, our dy dx becomes u dv dx plus v du dx. Remember, it's not v dv dx. No, it's u dv dx plus v du dx. Now, if our u is equals x raised to power 3, so our du dx will now be equal to, these are n term. Let's use our normal rule for differentiation. Remember the rule n(x(n minus 1). This is just a reminder. Now you now have 3, bringing it back here. This is a value of n. So you now have 3x raised to power 3 minus 1, which is 3x squared. So the value of du dx is 3x squared. Now let's do that of the v dx. Remember that where our v is equal to, where's our v from the question? Our v is sine 5x, and if you differentiate sine, you have cos. So our dv dx is equal to 5 cos 5x from here. So finding dy dx is equals u dv dx plus v the u the x, which is the same thing as our value of u is what? X cubed times dv dx is what? Our dv dx was 5 cos 5x times 5 cos 5x, then plus, what's the value of our v? Our v is equals sine 5x then times du dx is what? Du dx is 3x squared times 3x squared. That's the value. Now there's something common with these two. We have x squared, so we now have x squared in brackets. There's still x here, so we have x 5x cos 5x plus this x squared, so we now have 3 sine 5x, 3 sine 5x. This is the value of our dy dx. So when you talk about the product rule, with the application of this concept, you'll be able to solve any question that comes up in product rule. So I would like us to, at this point again, to solve one more question. This is now our question number 3. So when you have y to be equals x cubed dot sine 3x, so let it be this. So you say u is this and v is this. Remember the product rule. When we have y equals uv, then dy dx is equals u dv dx plus v du dx. So let's go further into our application. We have if u is equals to x cubed, then du dx. Remember the rule of calculus, you have n x raised to the power n minus 1. So du dx becomes 3 x raised to the power 3 minus 1, which is 3x squared. And v is equal to sine 3x. So if we differentiate this, we have 3 cos 3x. So let's look for dy dx. By applying this, the first thing we bring down here according to the formula is u, and our u is x cubed in bracket dv dx was what? Where's our dv dx? Dv dx. Okay, this is dv dx. Our dv dx is 3 cos 3x. Then we now have plus sine 3x. Then our du dx, we got 3x squared times 3x squared. Now if you do a proper collection of terms, you now know that with this we have 3x cubed cos 3x plus 3x squared sine 3x. Remember, these are dy dx. So you break it down, you have 3 here, so 3 is common. X cubed x squared, so you take x squared and you leave x cos 3x, then plus, you're done with this, plus sine 3x. So this is our final value for dy dx. So this is all about the product rule. So I would like to tell you at this point that thank you for joining us in this section. To refresh your memory on what we've just discussed, please take the test that will appear on your screen. Do well to always use this lesson note on the platform for a better information on the topic we've discussed. Always feel free to drop your questions, your comments on the comment section. We'll be very happy to hear from you. Thank you.